Hi, everybody. Hopefully this first one's going to work really well. I really don't want to do this a whole bunch of times. There are three possibilities for linear equations. The one that you see over and over and over again are equations that have one solution. You go through a whole bunch of steps, and at the end you have x equals a number. And unfortunately, there are two other possibilities. There is the possibility that you could have no solution, and that you could have an infinite number of solutions. In this situation, this is also called an identity. Let me see if I can write it. And basically what it looks like is this: 2x plus 3 equals 2x plus 3. Well, duh, of course 2x plus 3 equals 2x plus 3. No matter what value you put into an equation that looks like this, it's going to be true. I could put in x equals 1 and I'll get 5 equals 5. I could put in x equals -2 and I'll get -1 equals -1. Doesn't matter what number I put in, any value will make this identity true. This is called, and sometimes they'll ask you how many solutions there are. Well, there's an infinite number because there's an infinite number of numbers you could choose: 1 or 2 or 3 or 4 or 5 and so on. You could choose negative numbers. You could even put decimals or fractions in here. If you put a half for each side for x, you would end up with half of 2, which is 1, plus 3 equals 1 plus 3. Of course, 4 is equal to 4. So that's one possibility. Another possibility is to have no solutions. Well, how could that possibly happen? Well, here's how that could happen. I'm going to shift this just very slightly. What if I said that 2x plus 3 was equal to 2x plus 8? Well, clearly that's not true. This is not true. And when you go to solving it, in this case, if you solve it, you're going to get something like 0 equals 0 or 3 equals 3. But when you go to solve something that looks like this, you subtract 2x from both sides, and darn, you get 3 equals 8, which is not true. It doesn't matter what value of x you choose, there is no way to make this true. And of course, for one solution, you might have something that looks like 2x plus 3 is equal to 5x minus 9, in which case you can solve the equation and get an x equal to a number. So let's look at some examples. I'm going to do this one side by side and show you what they'll look like in your quizzes or in your practice. A very common mistake in this situation is to want to distribute the positive 3 to both of these. You don't distribute a positive 3. This really is a -3 in front of this x minus 4. This is plus a -3. So don't make that error. And we're going to go ahead and solve this. We end up with 2x plus -3x, or minus 3x, same thing. -3 times -4 is positive 12. And that's equal to 3x plus 8. Now I'm going to add the 2x plus the -3x, and I'm going to get -1x plus 12 is equal to 3x plus 8. I have lots of options. I can subtract 3x from both sides, but that's going to give me a negative value for in front of my x. I prefer to have positive coefficients. So I'm going to add x to both sides, and I end up with 12. This is just 12. This is 0, by the way. And this just gives me 12 equals, this is 4x plus 8, which is the same thing as 4x plus 8 equals 12. This actually has a name. This is called the symmetric property of equality. It says that you can switch: if A equals B, then B equals A. The last two steps is to subtract 8 from both sides, and you get 4x equals 4. And when you solve it, you divide by 4, and you get x equals 1. There is literally x is equal to 1, but there is only one solution for x. And so we say that the solution set would look like this. one inside of a set of solutions. Now in this situation, we're going to distribute our -2 to both parts. And I'm not going to do the little shift change here. This is 5x minus 4x. Hopefully you see that's minus 14 is equal to x plus 5. 5x minus 4x is 1x. Hopefully you recognize already that this is never true, because no matter what I subtract, if I subtract x minus a number 14 and I add 5 to the number, they're going to have different answers. But some people are going to go all the way to here, subtract x, and then they start getting confused. But don't worry, I'm going to get -14 is equal to 5. And that will never happen. So no solution is what I would write. Another way of writing the solution set is to say, I've got brackets with nothing inside of them. You could also write this, which says it's an empty set. All of those things are correct. Now let's look at another example. Now in this one, I'm going to have no solution on the left. I'm going to distribute the 2 to both parts, and I end up with 4x plus 8 is equal to 4x minus 10. And subtract the 4x from both sides, and you get 8 equals -10, which is never true. This is not true. It will never be true. So it is no solution. There is no way I can choose an x that will make this true. On this side, we have all solutions. And here's how this works. If I distribute this 2 to both parts, I end up with 4x plus 8 on this side, and I have 4x plus 8 on this side. Now, a lot of people get these two situations confused, and they could not possibly be more different. There is no possible value on the left and any possible value on the right. Any number I put in here will make this true. This is not only is it never true, it is always true on this side. This is called an identity. It's always true. So x belongs to the set of all real numbers. That's one way to write that. Another way to write that is to say that we have an infinite number of solutions. It's actually more accurate to say that we have any solution makes it true. One last one, I think. Oh, yeah. I wanted to do a word problem. So in this first one, I have 4 consecutive integers. Remember that consecutive integers are like x plus 1, x plus 2, x plus 3. There's the algebraic method for writing 4 consecutive integers. And this first part says the first and third integers have the same sum as the second and fourth. So in other words, this is the first integer, and this x plus 2 is the third integer. Have the same sum as the second and the fourth. The second one is x plus 1, and the fourth one is x plus 3. And what do we have here? 2x plus 2. And what do we have over here? 2x plus 4. And this problem has no solution because there is no way to ever make this true. Sorry, I made a mistake on this one here. I really wanted the first and fourth. Sorry, I wrote it wrong. And this one should have been the second and third. Don't know what I was thinking there. So now that I've fixed it, let's take a look and see what happens with this problem. The first and the fourth integers. The first integer is x. and the fourth integer is x plus 3. And if I take the sum, it's supposed to be the same as the second and third, which is x plus 1 and x plus 2. Sorry, so we're getting a little messy here. Well, this is 2x plus 3 on this side, and 2x plus 3 on this side. And we end up with an identity. Now, I can't say that it's any real number or that x can be anything because they specifically said that they're consecutive integers. But I can choose any number I want for x, and the 4 integers that I get it'll be true that the first and the last integer is the same as the middle pair. So let's see if that's true. 1, 2, 3, and 4. Add the first and the last, and then add the middle two, and you get the same sum. Now, this is true no matter where you go, and this is the proof of that. 2x plus 3 is always equal to 2x plus 3. So the first and fourth integers have the same sum as the second and third. Any solution, well, any integer solution will work. And we have an infinite number of choices. If I had started with 5, 6, 7, and 8, you can see that the first and the last add up to 13, and the middle pair adds up to 13. So hopefully you can see how these are different. This one has no solution where the first and third have the same sum as the second and fourth. But this one, the first and the last add up to the same as the second and the third. The last one, let's just do a quick matchup. Match the equation with the number or type of solution that it represents. So this one is 2x plus 2 is equal to 2x minus 3. And we want to see which one of that does it match with. All solutions, one solution, or no solution. This one says 5x minus 8 equals 3x plus 4. And we want to match it up. In this last one, we do need to simplify the two sides and see how they match up. So finish this one on your own. Hopefully you guys can see it okay. And that will be it. That.